We have made a ability system component and some attributes to work with in the first setup video to this series. Today we're going to go ahead and make our gameplay effects, which will be changing up these attributes. There's quite a lot to this to make this in a scalable and flexible, malleable way. So let's immediately get into it. For this, we're going to make a new blueprint, and we're going to go down to all classes and make this a basic object. There's no reason for this to exist in the world as an actor, so we're going to make this just as a basic object that applies itself and sticks around for as long as it needs to stick around, and then deletes itself. And we'll call this something like turn effects or gameplay effect. I'm trying to give them somewhat unique names compared to the actual gameplay ability system because you might get confused otherwise. So this is specifically a gameplay effect that gets applied within the turn-based system. So let's open this up. And here we start with making a new custom event, which we'll call apply effects. This is just the setup, kind of the begin play for our gameplay event. Because this is a base object, it doesn't have a lot of stuff like tick and begin play or anything like that. It's very bare bones. The reason that is a good thing is because it also means that the memory overhead and the constructing of it is a lot faster than making an actor would be. So here when we apply the effect, we need to know what type of effect it is. In my example project, I have 4 types of effects, which are instant, 4 turns, which is just for a set amount of turns at the beginning of every turn, apply this effect. Then infinite, which is just as long as this is around until it's explicitly removed, apply this effect. Temporary is mostly for the modifiers. You can use them on the base stats as well if you really wanted to, but it's an effect that applies itself and then de-applies itself whenever it's removed again. Hopefully it'll become a little bit more clear if it isn't yet as we go. For that though, we do need to make an enum type. So we're going to go into Blueprint, make a new enumeration, and we'll call that the effects type. Open that up, and we'll add our new enumerators, all 4 of them. We're going to make this instant, 4 turns, infinite, and temporary. With that made, going back into the turn effect, immediately what we do is we create a variable for the effect type, and we'll make that of type effect type. So we type in effect type as an enum. We make that instance editable, and then also on the right hand side here we expose it on spawn, because whenever we create one of these effects, we immediately want to be able to give in, hey, what type of effect are we dealing with here? And then we pull that in and we add in a switch node for that. So all 4 of these are going to do something slightly different, but in the end, all that they do is starting with actually applying the effect. And for that, we're going to make a function and we'll call that do effect instead. So apply effect is going to run do effect, and we need to have a couple of things set up here. So the effect that we're going to be doing needs to have a target. We need to know what the target is that the effect is going to be applying to. So we make that as a variable and call that something like target component. Because we're going to be not targeting an actor with this, we're going to be targeting a ability system component, which will also set instance editable and expose on spawn. Before anything else, we want to get this, right-click it, and turn it into a validated get. We want to make sure that whatever ability system component we're trying to apply this to is valid, that it exists. Because if it doesn't, obviously, we're not going to want to do anything with it. Then, from that target component, we're going to get the attributes. And just as we did before when trying to get attributes, we're going to for each loop over them, if it's valid, of course. And we're going to be trying to find from this split structure pin the matching name to the attribute that this effect is going to be applying to. So we also need to add a variable for attribute to effect, which will be a name, which again is going to be exposed and exposed on spawn. And that is what we will be comparing to here. So we're going to be finding the attribute in this set that we're trying to adjust. Now, if this attribute array doesn't have any attribute with this exact name, it's just going to do nothing, which is fine. But when it does find it, will go into a branching node, and then we need to decide, hey, what are we actually going to do with this, right? Which stat are we targeting to begin with? The minimum value modifier, the maximum value, maximum modifier, the current value, or the current value modifier. So for that, we need to make another enum, because we're going to do the exact same thing that we did before. We're going to make a switch node. So we go into Blueprint, we make an enumeration, and we call that the target stat. And opening that up, we effectively just add all the things that we have there. So min value modifier, max value modifier, current value. Maybe typing value for every single one of these is unnecessary now that I think about it, but here we are, and max value modifier. So this is going to be the enum that we decide that with. Going back into the turn effect, we obviously need that to be a variable. So the target stat will be of type target stat, which once again, instance editable, exposes on spawn. We get that, and we add in a switch on target stat so that we get a switch node with all of those options in it. Now, this is a little bit of work that we're going to need to do here. So bear with me. We're going to make a new function again, which is going to take in the current value and then calculate the new value and output it for us. So we'll make a new function and call that calculate new value. And for this, we're going to need yet another enumerator. We're almost done making new enumerators, but we just need a couple of them because there's so many different things that a gameplay effect can do. It can affect a number of different stats. It can have a number of different rules that it needs to follow. And now we need to make one for the math rules that it needs to follow. Does it need to add? Does it need to multiply? Does it need to override? Does it need to divide? You can also make one for subtraction, but subtraction is just kind of like inverse addition. So generally speaking, we don't add a specific one for that, but you can. Either way, you go into Blueprint, enumeration, and I call this one effect math, because it's the math that we do for the effects. So in this case, what I did is I just have add, multiply, divide, and then override as well, because sometimes you want to just specifically say, hey, this is going to be the new value of this stat. I don't care about anything else. I don't want to just add to it. I don't want to like do multiplication. I just want to give in whatever value it's going to be now. If you want to add in a separate like subtraction, maybe like exponent, whatever, you can add as many of these as you want, obviously, into the enumeration. We're going to stick with these four for now. So, to nobody's surprise, we're going to make a variable for that, which will be the effects math, which will of course be of type effect math, going to be exposed on spawn, and we're going to be using that here to run a switch statement with. Let's add in a variable as well for the magnitude of the effect. So that's how much we're going to be adding, multiplying, whatever with, right? So that will be the magnitude, which will be a float value, which again, we're going to expose on spawn because pretty much everything is going to be exposed on spawn, okay? We drag in that magnitude and we try to add to it. So we take this and then we hook this up to the beginning of our function to make it an input. And we'll call that input old value or current value, whatever you prefer. And then if we're adding, we return this, which we'll call new value. If we're multiplying, obviously what we do is we take the magnitude and then we multiply with the old value instead, and then we return that. If we are dividing, I think that you know what we're going to go with. It's important that you take the old value first for division, because the order of these does matter for division. So it's old value divided by the magnitude, which is going to be the return node for division. So hook that up. And it's kind of neat because for override, we don't even need to do any math. We can just say, hey, the magnitude is just going to be whatever the new value will be, right? This is the basic setup for this function. It works. I'm going to future-proof this a little bit because sometimes we want to know what the absolute change in the value is later down the line. And we can either come back to this function later to add that back in, or we can just add in a couple of extra nodes right now to figure that out. So I'll make a variable here. We'll call that absolute change. This doesn't need to be exposed for once. And on every single one of these paths, before we do anything else, we're also going to be setting the absolute change. So just add in a setting node for absolute change between the switch and every single one of these returns. And then for all of them, it actually kind of comes down to just taking the old value and subtracting whatever the new value is. So for the plus, that is this one here. So our magnitude plus our old value. We take our old value, subtract that combination from it. And we kind of just do that a bunch of times because we do the same thing for multiplication. So we take this, subtract our output from our multiplication, put that in there. It becomes a little spaghettified fairly quickly here. So what you can do for that is you can just get old value and hook that up like this instead to all of these so that we don't have the spaghetti going all over the place. Just looks a little bit more organized that way. You can actually kind of see what's going on a little bit better as well with it. So let's do that. There's still a lot of nodes going around all over the place, obviously, but a little bit less now. So then we also take old value minus the result of the division. And then for the override one, we just take old value minus the magnitude directly and put that in absolute change. Real quick cutting in here during the editing of this video. It's going to happen a couple of times during this video because there's a lot of stuff. We hooked up the minus node here the wrong way around. You do need to put in the magnitude plus old value, so that's the new value in the top here, and then the old value goes into the bottom. Otherwise it's going to reapply the same absolute magnitude change at the end as well. So make sure to go through and make sure that the old value is at the bottom and our new value is at the top. Got to do that with all of these. So I seemingly messed up them all. So again, just got to make sure new value at the top, old value at the bottom. So now we have our function that takes in the old value and puts out the new value based on our effect math. So going back into the doEffect function, we can now get our calculate new value, and we're going to put in one of those for every single one of these pins. So there's going to be a few of them, which is also going to be a noodly mess. Bear with me, we're going to make it through, I promise. So we hook all of those up just like this, fairly straightforward. And then the old value that we provided, let's make a little bit of distance here, will be taken from the for each loop. It's a little bit weird though, because looping over the for each loop, everything that we go through here technically are copies of the original values, not the actual original values that we're working with, just due to the fact of how Blueprint deals with the for each loop. So what we actually want to do is we want to get a reference, not a copy, but a reference from the original array, and we just get it at the array index that we're currently at. This way, we get a reference to the actual index of the actual array, so we can edit it and it will reflect properly back into the components. So we're going to break that, and we get the stat attributes, which we break again, and that's going to give us our minimum value and all that other stuff. These are what we provide in for all of our calculate new value nodes. And with all of this, it's not really that important yet that we're using a reference, but that will become important in a moment because it's going to do its math and output the new value. So we're going to come over back here to our break attributes. We grab our stat, just pull that out, and then we set member in stat. This requires it to be a reference. Otherwise, we're going to be setting it in a copy and it's not actually going to like pull through. So in this case, we go in the details panel here and we set this as pin for minimum value to be enabled, and we set that through there. And then we just kind of like copy this over a whole bunch of times and just update which pin is available. So we do value mod for the second, then we make sure that it's the max value for the third, and so on and so forth. So just copy like 3 of them over, the max value modifier, next one would be the current value, and you kind of get the point at this point, I hope, and then the current value modifier as well. Make sure that if you just copy them over like I did, you can just double click to add a reroute node in here, and make sure that all of the struct references are also hooked up in there, because otherwise it's not going to be able to set them to the actual struct. And this is now effectively a functional gameplay effect. Now, there's one thing that I do want to do, and that is I want to add a event dispatcher which says update attributes, which is going to take in an input of either just a name of an attribute or the attribute as a whole. Kind of depends on what you want to do. Largely, just sending through the name is probably enough. I'm just going to send through the entire attribute so that we have all the new values to it as well. We'll call that attribute. And after any one of these parts, we're just going to be calling that out. So we hook all of these up to that so that we have an event dispatcher that everything can listen out for. So when you like damage something, for instance, you want to be checking, hey, after the damage has been applied, are we now at 0 HP? Because if we are, obviously, you want to like kill that character or whatever. And the thing that we're going to be sending through is the output from this getting node. So you get that and you pull it all the way through to there. And then after all of that, we just return. So that it ends the function. It doesn't need any return values. The return node is just purely there to stop this loop from going through the rest of the attributes once it's already found what it's supposed to be looking for. Now, you also can implement the built-in clamping for the minimum and maximum here, because obviously your current value should not be above or below the minimum or maximum value. So we have our current value here. We're going to put that into the clamping float node. And then we want to clamp this between minimum and maximum. Now, the way that we can do that is either just by getting the min value and adding to that the minimum value modifier and putting that in there as the minimum value. But we made a function for this, if you recall. So let's make a little bit of room here. We have our target component that we're working on as a reference. So we can just get minimum attribute. And we can then also get the maximum value for that attribute. Fairly straightforward and easy, just like this. So if we hook all of that up kind of a bit like this, we just need to give in the name. But hey, don't you know, we have the attribute to effect as a variable as well. So we can just give that in as a name too. And then we can easily pull these through. And now our current stat value will be clamped to the minimum and maximum with their modified values applied as well. Cutting in here during editing real quick. It's been a long day. Do make sure to hook up the get minimum and maximum attribute things to the right line of things, because we hooked them up here to the bottom thing where I hook it up to the current value modifier. Obviously, we want to do that with just current value instead, because otherwise it's going to always set you to 0, which obviously we don't want to do that. So make sure to hook this up in the proper line. So again, that is the current value goes to calculate new value, goes to the get minimum and maximum attributes for the clamping nodes, and that sets the member stat current value. This is the bulk of what the gameplay effect will actually be doing. So we're actually pretty close to having this working now. So we can go back into the event graph and at apply effect, we can just do effect at pretty much like every single one of these anyway, right? Because if it's an instant effect, we just want to do the effect immediately. If it's a turn effect, we want to do it and then do a little bit of like turn counting. If it's infinite, we just want to do it and that's it. And if it's temporary, we also want to do it and that's it. Now we need to add in another event. So let's add in the custom event for end effects. So end effect. And this needs to check the effect type as well. Specifically because the temporary effect is going to be dealing with its own like absolute magnitude that it applied and going to be reversing that. That is why we made that absolute magnitude change variable before. So let's switch on effect type. And here we pretty much just, because we calculated the absolute change in magnitude, what we can do is we can set our effect math now just to be like hard coded to set to add, because we calculated how much it subtracted. If this is a negative number that it subtracted, it added something. It's now going to subtract it, whatever. Again, adding and subtraction are kind of the same thing, just in opposite directions. And we're going to set our new current magnitude to being our absolute change. multiplied by -1. So we're just going to add back in however much we took away or the other way around. And then we will do the effect to reverse it back to what it was before we applied this temporary effect. Now, in order to finish this end effect, we also do need to hop over real quick into the ability system component, because the ability system component is going to keep track of what effects apply to it. Because at the start of every turn, it's going to need to like run the effects that it has actively on it. So we'll make a array for that, call that active effect, and that will be of type turn effect, the object that we've been working on this entire time. And we're going to make that into an array. In a moment, we'll actually make the function that adds things to this array. But for now, we just need this array to exist so that within the turn effect, when we end the effect, what we can do is we can get our target components and we can get the active effects, and then we can remove from it. So we can remove an item, and we're going to be removing just a reference to self. So this effect is going to be removing itself from that array. And the wonderful thing about Unreal Engine's base objects is because Unreal Engine has its own built-in garbage collection, we don't need to explicitly destroy this object. Just as soon as it's no longer available as a variable that's set in any object, or part of this array in this case, Unreal is just going to clean up this effect all by itself eventually. You don't need to worry about explicitly destroying it, which is kind of nice. So we just remove this pretty much like any case, and then also add in the instance. So yeah, this is pretty much just like removing it from that array, but if it's a temporary effect, first reversing whatever it did. So now that we have that end effect thing, we can also hook that up immediately to instance, because instance just does the effect and then immediately ends the effect as well. So we can end the effect. And the last thing that we have to do is to make a turn counter for the 4 turns effect types. So we make a variable for that as well, which will be the effect turn counter. That's going to be an integer, which obviously is going to be exposed on spawn and instance editable. And then we just get that counter and we decrement from it. So that's minus minus, so that we take away 1 from it. And we just check, hey, is this now less than or equal to 0? Because if it is, we just applied it for the last time and we can end the effect as well. And just like that, we have a functional gameplay effect. Now we just need to set up the code to apply it, because what good is a gameplay effect if we can't apply it, right? So for that, we're going to go back into the ability system component, make a new function, and we'll call that something like apply effects to target. And in here we're gonna construct a object from class, and we're gonna be constructing an object from the class that we give in to it as a parameter. Now this is just going to be a normal object class reference. We obviously only want to construct objects of the type turn effects, so we look for turn effects and then we make this a class reference. Now, that initially might not get you everything that you need, so you disconnect this, and when you reconnect it, it will show up with all the exposed on spawn things. So we pretty much just hook all of these up right into the parameters of this function as well. It's just going to all send them through. So we do this. The effect math didn't want to connect up for some reason there. If it does that, just try it again. Probably put it just in the wrong place, and just like that. Now, there's only 2 things. I also didn't set the attribute to effect. Now, there's one more thing that we want to take a look at, and that is the outer of this object. The outer of the object is kind of like the parent, the thing that is responsible for this object, that takes care of this object, that without it, this object like doesn't have a place to exist within like your game code. So you want this to be applied to the target components, because what you don't want to have happen is a character applying an effect to a different character and then getting removed, which means that the outer object of the effect gets removed, and that's all kinds of weird. So you want the outer object of it to be the actual component that it will be affecting. So you can just pull those through like that, and that will be all fine and good to go. Now, if you click on this, you can rearrange the order of these to be in a slightly more sensible way. So maybe like having the name of the attribute up top, and then the effect turn count I'm going to keep at the bottom. The effect type, probably the target component also quite high up. You can order these however you want, really. Doesn't effectively change anything, but it might be nice to like order these in a way that makes sense to you personally. Quickly during editing, I'm cutting in here because I made this class a parameter for the apply effect to target function. You actually don't need to do that. You can just make this be a turn effect class that it spawns in, because we're given in all of these values through the parameters, and we're always going to be spawning in a turn effect. You can set this up a little bit more like the original gameplay ability system, where the gameplay effects themselves are always like separate classes, in which case you don't need to give in all of these values one by one every time you call apply effect to target. I personally prefer doing it this way, because it saves you having to make a separate blueprint for every single variation of damage that you possibly could want to do. Then when we have constructed this object, we do want to bind to update attributes. And what we're going to be binding to that will be on the target component a specific function. So let's actually pull off of this, and we will create an event, and we'll make a new matching function for that, and we'll call that on attribute updated. For now, we're not really going to do anything with this, aside from maybe also making a new event dispatcher on this, which we'll call attributes updated as well. You can give this a different name, maybe, so that it's a little bit more clear that this is the component version. But all that needs to really do is copy the signature from on attribute updated. So we find that somewhere in here. You might need to compile first for that to be in the list. So on attribute updated, and we just kind of like send that through. So that way we can subscribe to this on the components instead of the individual effects as well. The effect just sends through a message to the component, and then the component can send through that message to whatever actors might be listening out, right? Just makes it a little bit easier to deal with. But we do want to make sure that we do that on the target component and not on the component that is sending the effect. So the target component will be the object that we link this to. Then we get our effect type, which is just the input parameter that we have here in the function. You can, again, get these as just nodes in your graph. They'll be marked with this little F icon so that it's clear that these are function inputs. And we will do a switch node on that as well. Because we now have this effect that we constructed. If it's an instant effect, we just immediately want to start applying this effect. If it's a temporary effect, we also want to immediately apply the effect. However, if it is an infinite or a effect that lasts for a certain amount of turns, what we want to do is we want to get our active effects, and we want to add unique. We add unique just because in case you might accidentally run this twice. You shouldn't. But you're going to be adding the constructed effects that we just made to this array. And don't immediately apply the effect either, because we're going to be applying this effect for the 4 turns and the infinite at the start of every turn in our like battle scene instead. So then we simply add a return node that both of these hook up to, and now we have a way to apply our stuff. If you want to, you can also add in a reference to that created effect as an output, just in case you want to do something out with it. So you can call this like effect reference. That way you can easily get the effect that was just created and have a reference to it just in case you need it or you want it. So with that, let's just add in a ability system component just to our BP third person character for now, because we don't really have a battle scene or anything yet. So what I'm going to do is I'm going to add a ability system component to our like just overworld character, for lack of a better term, which is going to have a attribute for HP by default, which is going to have 100 max and 100 current value. And then when I press a debug key, so let's do debug key F or something like that, we get in our ability system component and we apply effect to target. The target component will be just itself. For that, it might be nice to, in the ability system component, just also make a apply effect to self, where we just kind of get apply effect to target and just make the target component a reference to self, and still just hook through all these other things as parameters. Just so that we have anything, if you want to apply an effect to self, like healing, it's a little bit more straightforward than having to also then hook up the target component, because it's going to confuse you. So you can apply effect to self instead. You see it doesn't have the target component anymore. It's just a little bit more clear. And what we're going to do is we're going to get our HP and with a magnitude of -10 instance at the current value, we're going to be adding. So every time I press the F key, I will lose 10 HP now. The way that we can test that fairly easily is just to add in a tick event, get our ability system components, obviously, and then get attributes, current value. We're going to be getting our HP, and then we print the value of our HP like that. And I'm going to just print this with a duration of delta seconds so that it doesn't spam my entire screen full. So now we will be able to see that if that pop-up for Shift F1 goes away, I have 100 HP in the top left corner. It's a little small, hopefully you can see it. If I press the F key, it goes down to 90 and then to 80. And then I can keep doing that until I get to 0, at which point it won't go down anymore because it is getting clamped to the minimum value of 0. If I go into my ability system component on my character here, and I set the minimum value to be like 15, you'll be able to see that it will stop at 15. So I can go down, that pop-up needs to go away real quick. 60, it's 50, it's 40, it's 30, it's 20, and now it's 15, because it doesn't allow me to go down below that. If I add in a value to like that modifier that we had, so I have a minimum value base of 15, and then it's temporarily like modified to allow me 10 more minimum value, you'll see that now the minimum value that I will practically be able to get to will be 25. So everything works as expected. We have attributes that we can now, with gameplay effects, change around. Now, we also obviously need a turn-based battle to make use of like the turn-based effects, that kind of stuff. We'll do that eventually. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Sergey Thomas and Mauricio Farias. And my Cave Student tier supporters, Oiku and Earl Monsville Urno.